Some of you are obviously a little bit curious about what life is like as an independent paleontologist, especially if you have huge numbers of fossils to deal with. So let me show you our spare room, and try not to laugh too much. If we were employed as paleontologists, we would have offices, lab space, museum facilities. And we've got the museum, but that's 4 hours away, and they'll take the specimens after we've published them. So at the moment, we really need to find space where we live for all our fossils. And when we are working on a site like Castle Bank, it is endlessly productive. But we're restricted to good weather. So we have to wait until the summer when the rock has dried out enough, when the light is good enough. And at that point, we can work there quite extensively. And, we'll often go 2 or 3 days a week. And you can collect quite a lot. I mean, a good day in the field will have 6 or 7 boxes like this, full of little chips of rock, all neatly packaged up. And they've all got to go somewhere. Usually what we do is sort them out, unwrap them, prepare them, put them in little boxes as soon as we come back from the field. But in a good part of the season, you can't keep up with that, especially when it comes to photographing and so on as well. They just start piling up. And if you want to be able to find where your specimens are again, you need them in some sort of order. So in the winter, we end up doing quite a lot of sorting out of specimens that are being collected, piled up into boxes of, say, just sponges, and left at that. So it's got to that point of the year now when I'm trying to sort out some of the sponges. Just 1 or 2. And obviously the ideal place for that is the spare room, because I don't think there's anyone planning to stay anytime soon. I hope not, anyway. I mean, it's not too bad. So, I mean, that's the bed. Yeah, that's not too bad. A little bit lumpy, perhaps. But, I've seen worse. And inside these boxes, there are quite a lot of little boxes. So we actually get these big cardboard things from the local market that turns up once a week, and we save them the bother of recycling things. But then these little cardboard boxes, we have to fold up ourselves, and we have to buy these in bulk each year to keep us supplied. So once we get some stuff published and put into the museum, then we can get some of those little boxes back. But it actually adds up to quite an expense in the end. But it's necessary. And you can see that when you start looking at all of the sponges that we have, and yes, there are more boxes over there, and I think those ones are empty in the corner, probably. We've had to use all the little weird tables we can find. I mean, where on earth did we get that thing from? That's a strange table. Huh, very odd. No idea what that is. Some sort of weird retro thing, I guess, but, Right, let's have a look at what we've got here. Some of these specimens have tiny little paper labels stuck to them with a number on. That's not a museum number, it is our working database number. So anything that we have taken photographs of and catalogued and databased on an online system, we have little paper numbers so that we can find the things again. Most of these specimens do not have little paper numbers on them. A lot of these are yet to be studied properly, they're yet to be identified fully. We know roughly what they are, but there's a long way to go with the full descriptions. And in many cases, we can't actually do the full identifications until we get more material. So we might find that you've got a sponge like that, and you're not quite sure what to do with it, even with the microscopes we've got, until you get a second specimen that shows a little bit more of the fine detail of the skeleton, for example. And so you do end up with a whole array of sponges that we just haven't had time to photograph, database, and so on, because we don't have large numbers of students at our disposal that we can put to sort of slave labour. This is, of course, only the sponges. All of the other groups are in other spare bedrooms, dare I say, and on the landings and in studies, and yeah, there's quite a lot more. I mean, sponges are one of the most abundant groups, and we collect more of them than we do, say, the Didymographus, because there's only so many of them you need. But there are a lot of sponges here. And trying to keep track of them, trying to organise a collection like this is not that easy, because there's a high diversity too. And as I say, almost all of it is undescribed. We've done, 3 papers on sponges so far, and they were each describing one species, basically. So there's a lot more to go. And if you want to describe this one next, for example, this lovely little thing with a sort of jug-like thing with a lip at the top, interesting little sponge, you need to know where all of those ones are and put them in one place. And it turns out that we've got about 3 or 4 specimens of those, which we can then have sorted out and put down into a little corner of the tray like this. So there's one, there's another one, and there's another couple that might be the same or might not. I'm going to have a close look at them, see if the skeleton actually matches up. And that's all very well, but you've got to go through a lot of sponges before you've sorted out which ones are which and can put them together like that. So a vital part of the process is to put the sponges that are similar to each other in one place, so that when we do actually want to go back and describe them properly, then we don't have to hunt through the whole collection of hundreds of them in order to find the ones we want. So some of these boxes consist of only one species. In this box over here, it actually says surplus. It's not strictly surplus, but these are additional specimens of Taganium avalonensis, which we have described already. So the name has been published, it's been formally described, and these are all extra specimens that we have found since then, or which weren't included in that paper. And the reason something like this is important is that you can then do things like ecological studies, if you're lucky, look at things like growth patterns and so on, which you need lots of material for. That is not going to go to waste by any means, but at some point we'll have enough material there to be able to look at the detailed growth patterns, distribution patterns, ecology, that sort of thing, and see what that tells us. Now, there's lots of other boxes here, some of which consist of single species. So that layer down there is all one species, which is probably the most common sponge. We don't collect all of them because there's a lot of sort of grotty fragments that are actually not that good, and we do see them every trip. So those are the best ones we've collected over the years. And then there are related ones which are multiple species here. Some quite nice things, actually. Quite intriguing sponges in here. These ones will take a lot more work. In fact, all of these, I think, are new species of ascosponge, and they probably all fall closely together within one new family. Let's see what else we've got. There's over... Oh, this is an interesting one. We have a box here of elongate sponges. All uncharacterized beyond that, but sort of tall, thin, slender things, which have... Well, there's several species in here. That much I'm sure of, but I'm not sure how many. I think probably about 4, to be honest. But there's lots of tall, thin sponges of probably multiple different major groups, but it's going to take quite a bit of work under the microscope to figure out whether they're hexactinellids. In some cases, it might be ascosponges. They might even be demosponges, 1 or 2 of them. I mentioned demosponges, but they are very, very rare here. So we have one little row up there of what appear to be demosponges. They need proper study, but they're ones I put aside at the moment as probably demosponges. They include sort of big sort of brush-like things but with lots of tiny spicules. It's a little different to the ascosponges. And then there's a single thing there which appears to be the oldest known catetid sponge, one of these massive, later on they're reef-building sponges. And we found that in a single little siliceous concretion. So there's the odd thing like that turns up. Even after 5 years of intense collecting, we have single specimens. Speaking of which, most of these, which are all ascosponges, are single specimens. So this one here is something we've not seen again, a weird thing with a little sort of pedunculate stalk. That might actually be a Coya rather than a Coyaella. There's a couple of other things, a possible leptomitid in this one. There's a couple of things I got sort of tentative names on because I've sort of written them up but not published yet. So that's a Pyreneid-like thing. There's possibly a Linica-like ascosponge. All ascosponges, various types. Probably about a dozen ascosponges I think we have in total. And if we go on to the next box up here, these are all Coyaella. So there's one species of that we've described. I think there's another 2 or 3 species there to be found. And then there's a 3-dimensional, much more complex thing called, well, possibly Corniculospongia, but that's a known genus, but it again needs... Starting to get the idea there's a bit of diversity here, but we haven't really even touched the surface of it yet. These are not Rossellids, these are reticulosans. So things like Cyathophycus, which is quite a common one from the Ordovician and Silurian, quite diverse. We've got 2 or 3 species there. Various other reticulosans. We won't go into the detail of that. There's a lot more to do. We have over here, if I can work my way through the piles of boxes. There we go. And here we have a whole box of another single species, which is an odd thing that actually has a sponge on a stalk. So there's a long slender stalk of spicules, looks a bit like that little sketch there, just like that, with an asymmetric sponge, always asymmetric, coming off one side. Now, is that a Hyalonema type thing, like a modern stalked hexactinellid, which has a sort of a morphology very like that? Or is it something else? It's actually quite difficult to tell, and this is the reason we have so many specimens, because the spicules of the body are absolutely minute, to the extent that I can barely see anything. So far, we've not been able to do much with this, including even working out which major group of sponges it belongs to. I mean, it has to be hexactinellid or stem group hexactinellid or something of that nature, but beyond that, we can't yet tie it down. So we're going to need more material which actually shows the critical details, and then all the rest of that will start to come into focus a bit better and we can actually describe it. Oh, over there we've got another ascosponge, probably a Haptonia, which is a Burgess shale genus, something a bit like it anyway. And then there's boxes here which are just bits of sponges put aside for taphonomy, things with a bit of preservation of the original mineralogy in the spicules, for example. Need to get some of those into the electron microscope. That's all well and good, and that's got us up to about 30 or 40 species, I think, so far. But there's also these, 5, 6 boxes over here. And these are mostly what we can only describe as hexactinellids. So it includes some really quite lovely material, and some quite big sponges like this thing here, if I can keep the shadow off it, and which have a thick, complex wall. You've got lots of internal cavernosity. You can see this sort of reticulate structure to it. There's more like that one has a sort of a thinner wall, but is a larger sponge. There's lots of other tiny, well, relatively small ones, rounded ones, ones with different types of wall thickness, different skeletal arrangements, and it keeps going, box after box after box. A lot of them are very, very small, which is a challenge because you're not totally sure whether those are juveniles of some of the bigger ones. Some have more detail in, and you can see I've got these little sketches in the boxes just because it's far easier to look for those than it is to look for the individual sponge. And a little flask-shaped thing, that's quite a fun one. And what we got up here? Oh, well, we have... that's quite a nice-looking one, isn't it? There's actually a cluster of them on top of each other. There's weird mushroom-shaped things. Those are quite fun. I'm not totally sure those are hexactinellids, but they're something interesting. And then we have up here things that look like that, which is really, really interesting because some of these look just like some of the things we've been collecting in Angie from the latest Ordovician at 444 million years. These are 20 million years older. They're about 462-ish. And that is extraordinary if we have actual stem group Rosselids in this time interval as well. Because you remember in the last video, we were looking at how we can get so much early diversification of the Rosselidae in particular, and we were trying to narrow that window down to see exactly when this diversification happened. And those seem to be stem group Rosselids. But that little thing there is one I have already written up but not published yet, and still sort of polishing it and working out a few more details and adding a couple of specimens maybe, or a couple of species. So that thing is a crown group Rosselid. And there are quite a lot of others in here that probably are crown group Rosselids as well as possibly some euplectellids, possibly some other groups. One of the ones we described is a possible hyalonematid, but it's something in that group of sponges in general, that sort of wider area, hyalonematids or ferronematids. And yeah, you can start to see the problem that we have. It's just almost overwhelming. I say almost. These two boxes here are full of sponges that have not yet been sorted out. And it's not just two boxes, because these are multiple layers deep. Let me just move this one to one side for you. And yes, there are multiple layers of cardboard in there, each of which houses yet more sponges. A lot of this is going to be rubbish stuff that ends up going in boxes like that, which is basically unusable bits of sponge fossil that might be useful for taphonomy or something one day, but we're not going to get any taxonomy out of them. And some of those look quite interesting. I mean, look at that. Great big thing. And at some point, I'm going to have to go through all that and get them all organised into these boxes as well. That's going to be a lot of little boxes. But it's a sort of thing where a single specimen can make a big difference to understanding what it is that we're looking at with some of these sponges. Some of the difficult ones, you just need that extra little bit of information which will tell you what it is that this thing belongs to, which group of sponges, whether you can name it. Yeah, so how many species are there here? It's a very difficult question. And my guess, as I was trying to tot them up earlier, very approximately, is that I can get up to about 40 species quite quickly. And then you have to add the hexactinellids on top of it. And I would say there's probably between 40 and 60 species of these hexactinellid-like sponges, with the possibly Rosselids, the possible various other things that are often difficult to identify. But these things are diverse. So let's have a little think about this. What does this tell us? What is this total diversity like? How close are we to the end of the fauna? How many more species are we likely to find here? So one of the things we really want to know about this is how close we are to the total diversity. Are we almost there? Is there a lot more to come? And there's quite a lot that we can do to kind of address this. But for that, it's useful to have people who have actually collected at the site quite extensively, and that'll be her too.
Hello, everyone.
So, what do you reckon? How would you rate our collection of sponges so far from here? Is it anywhere near the end? And how would we know? How do we analyse this sort of thing?
Oh, we certainly do have a lot of sponges.
Yep. Oh, yes.
But some species we have quite a lot of.
Yep.
To the extent that we don't even bother collecting it anymore. Mm-hmm. So the Teganium and the little Koyala.
Only it's not Koyala.
Well, it's not
yes.
Koyala, but I think we're just Koyala.
Yeah.
So we've got lots of those, but then you've got lots that you only have one of.
Yes, and I'm trying to very loosely approximate to that sort of diversity level abundance. And what I've come up with is I think we have about 10 species that have more than 5 specimens.
Okay.
And some of them are only a few more, sort of 7 or 8.
Mm-hmm. Out of how many?
Well, that's the question, isn't it? I think we're looking at conservatively 80 species.
Okay, of which, how many was it? You said 10 you've got more than 5 specimens of.
Yes, but we have maybe 2 or 3 that have 100 specimens. Mm-hmm. Then there's a couple with 20 odd. Mm-hmm. And then it goes down to 10, 8, 5. And almost all the rest are 2, 3, or 1.
And of course, when we go back collecting again, we are not surprised when we find a new sponge.
Not at all. And quite often you can't tell is a thing immediately in the field, because, and you've seen what a lot of these things are like. These little hexactinellid-like things are really hard to actually identify. And you can see that they're the same when you get good examples and they're relatively distinctive shape. But there's a lot more work that I have to do here just to pin down how many we've got. And the numbers that I've got will drop as I start to recognise that one is similar to one in a different box that I'd overlooked. But I also know from experience that when you start looking at them in detail, some of those will be complexes of 3 or 4 species. So then the number goes up again. So at the moment, it's sort of, I'm saying conservatively about 80. Between 60 and 100, I think, is a pretty good guess. And but I know that number is going to go down at some point in the process, but then we'll go back up again.
I mean, it's not going to be the full diversity, because if we keep collecting, we will find the even rarer ones. But it's going to take us a while to get many more even rarer ones, I think. So, I mean, all right, we can't give estimates of what we're going to find this year or anything, because it is a bit random, but do you think we might get 5 new species this year? 10? I mean, we're not going to get 15 new species of sponge this year, probably.
Maybe. It's really difficult to know, isn't it? And it also depends to some extent on exactly which beds you're looking at. Yes. So we can very easily get 4 or 5 new species in a day, but then the next day we won't get any. So it also depends how close we are to the end of this diversity curve. Mm-hmm. So if it turns out that the next a few times out we start getting 2nd and 3rd specimens, then we can be fairly confident that we are starting to get towards the end.
That would be nice, wouldn't it? Because so many things we have 1 specimen.
Yeah. And there are analyses you can do based on the number of singletons versus the number with 2 specimens. But it requires assumptions, so they should be from the same population, which of course this is slightly time averaged. Mm-hmm. And the other thing is, when we have 2 or 3, they're usually on the same slab. Mm-hmm. It's a little cluster of 2 or 3 next to each other, and then we never see it again.
Yeah, and leaving aside the sponges for a moment, with the more unusual stuff, I carefully didn't say interesting stuff.
I should hope not, otherwise people might get slightly annoyed.
Well, yes, they might.
Yes.
But with the more unusual stuff, we very often have the problem that we might have a second specimen of it, but we don't necessarily realise because it looks a bit too different.
Yes.
So sometimes, at the point where we start going back through boxes, we might be able to say, oh, actually, these 4 or 5 things are just different views of that one.
Yeah, that is a thing with soft-bodied fossils. Yeah. It's an issue that comes up repeatedly. But in the sponges, it's not so much of an issue because you don't really get them in different orientations unless they're spherical.
Yeah, and sponges do tend to be the same all the way around.
You do tend to get differences in preservation. So I think that there's one with lots of spicules sticking out everywhere, one of these rossellids. Well, I think we may have a second one where the projecting spicules are not preserved. It's only the soft tissue. But the spicules within the body wall look very similar. So that's one where I've tentatively put it in the same species for now. And there's all these aspects that you can only pin down with quite a lot of work down the microscope. So we're not going to be able to give a definite answer. I mean, people ask us, how many species of sponge have you got? Or how many species are there in this biota as a whole?
Oh, blimey.
We can say it's a lot more than we had when we started. So I think in the first paper we suggested we had about 170 species.
It's a lot more than that now, simply because we've done a lot more collecting.
Yeah, and you just compare particular groups where we know fairly well. I think we had 40 to 50 sponges, I think was our original estimate, and it's way past that. It's probably about double. Paleoecologists, I think we had 5, and we now think it's over 20. So it's an ongoing process.
And even things like brachiopods, where I think we had 2 or 3 at that point, but we've done a lot more collecting, and we now have single specimens of 3 or 4 more species.
Oh, more than that.
Yeah.
And I think there's 5 or 6 species, and these are things with a hard mineralized shell where we have a single specimen.
And brachiopods are reasonably easy to identify because they've been well studied.
Yeah, there's been monographs of the rocks of this area, of this age, and some of these things are just not in those monographs. So there's a lot more that we haven't found yet and haven't identified or interpreted.
Yeah, and the brachiopod fauna anyway is probably quite nondescript. It'd be exactly the same as any other rocks of this age in the area, pretty much. But because we've done so much collecting, we're getting the really, really rare things, which is why we got single specimens of lots of them.
Yes, and this leads on to a really important point about the sponges. Because what I was saying about in Angie, you have these rossellids are everywhere. These are hexactinellids, the derived things. But we haven't got the deep water like we have at Angie here. It's relatively shallow, it's relatively sheltered as well, and we're guessing something like 70 metres water depth, between 50 and 100. But it's in a volcanic caldera, so it's protected from the waves to some extent. So that might be the sort of place where deeper water sponges might make an appearance in the shallows. And in this case, it's the hexactinellids in general that are the rare ones. There's this thing on a stalk, where we do actually have quite a lot. But the rest of them are, single specimens for the most part.
Of course, the other difference between here and Angie is that this is a lot older.
Yeah.
So it's not just a water depth difference, potentially.
It is, yes. But the question is, how far back can we trace these modern hexactinellids? And we're getting some of these rossellids, some which look remarkably similar to some of the ones we got in China, the stem group rossellids, which, that's unexpected. And that is not what we anticipated at all.
No, and it does mean that these taxa were reasonably widespread, because we're on a different continental block from South China. We're quite a long way away at that point.
And of course,
but if we're talking about deep sea animals, they can spread all around the world, potentially.
Exactly. Yeah, you do find populations tend to be pretty homogeneous across the world in the deep sea because they are cold water specialists. Their temperature doesn't change that much around the world, so you end up with a continuous community in many cases, not entirely by any means. But so in terms of the implications for the previous video about the rossellids, it really does look like we have rossellids, stem group and crown group, probably, in this fauna. Not published yet, so you can't really quote that as verbatim until it's actually out there, but it looks like it. And this is now the middle Ordovician. We're 20 million years older here. So in terms of narrowing that age gap when this diversification happened, it looks like we can narrow it back to before the Middle Ordovician. And that's quite scary.
Yep.
And it just makes you wonder what on earth we're going to do next. What are we going to find next? And more to the point, what are we going to do when we have someone who needs to use a spare bed?
They can sleep on the sofa.
Okay, yes. We do have a sofa.
Yes.
Yeah, I would recommend that there's a single spare bed upstairs as well, but I think that's covered in worms.
Yes.
Oh, and some arthropods.
Yes.
Yeah. Yeah, not brachiopods at least. So at least, they'd have an interesting night's sleep.
Mm.
Yeah.
So,
Welcome to our lives.
we have quite a lot of rocks, it's fair to say.
Yeah. This is just Castle Bank.
Oh, yes.
Most of the less important stuff is in the basement. Did we mention we have a basement? How many floors have we got? I keep losing count.
They're all full of rocks, it's fair to say.
Not all full of rocks. And there's only probably about a dozen rocks on the middle floor, apart from the thin section collection.
Mm.
Yeah. Do they count as rocks? Not really. They're just slides.
They're specimens, aren't they?
Yeah, I guess so. But yeah, top floor... Yeah, the further it goes from the middle of the house, the fuller it gets of rocks, basically.
Yes.
Yeah.
Yes.
Except temporarily like this.
We need to publish more.
That is a thing we need to do. Yeah. You're helping. Just by following these videos and so on, you're taking up a lot of my time in a very good way, because it means I don't have to spend my time doing lots and lots of other things.
Well, you are forcing him to sort out some of these sponges, which is really useful. So if you'd like to leave lots of comments about how you'd want to see lots more sponge videos, he'll have to do some more sorting and then we can get the spare room back.
Come on, there are limits. This is an honest audience we've got here.
Exactly.
Oh, yeah.
Honest and very discerning.
So how many boxes of graptolites are there?
Some. Not as many as sponges.
I think we need to do something on the diplograptids from here as well, because that is a very interesting story in a very similar way. And there aren't nearly as many species.
That is very true.
Yeah. But the ones you got are quite interesting.
They're rather nice.
Yeah. I wouldn't go that far, but they're interesting. I have my priorities, what can you say? Right, okay. Thank you very much for listening again. And this was hopefully a little bit of an insight into how we do stuff when you have to make do in your own house. And it does make it an interesting place to visit. At least, well, you'd think so, but I'm not quite sure when the last time we had a relative visiting us was.
About 6 months ago.
Oh, but that was the first time in years.
Yes.
Oh dear. They don't know what they're missing. If you're watching. Right, we'll leave it there. Go and see if this actually worked. Slightly different setup to normal, hence holding a little microphone in mid-air. I mean, it works well in my beard, but that's the problem. There are limitations. Right, ta-ra for now.